All right, the last example that we're going to look at is graphing the parabola given the standard form of that function. All right, so we're going to continue with the example that we used for finding the vertex in the chart. All right, so I have that x squared minus 8x plus 12. We already calculated that vertex in page 1 of the notes. Right, so I'm just going to make that note that the work is on page 1. All right. Normally, if we had a function where we didn't know what the vertex was, we could use that formula of that negative b over 2a and evaluating it to find the vertex. All right. Once I find my vertex, which is my first step, I want to go ahead and find some x and y values in order to plot some points on that parabola. All right. So I'm going to fill in my x and y coordinates of my vertex in the center of this chart. All right. And I'm going to go ahead and plot that vertex on my coordinate grid. So I have over to the right 4 and down 4. All right. So I'm going to plot my vertex. And the reason why I want to put it in the middle is because the general shape of my parabola is going to be that U shape, like this. So I know that it's going to come downward, left to right, go through that vertex and come back up. So I want to find the points that are directly next to or to the left of my vertex and directly to the right of my vertex. All right. So my second step, right, I want to find those points. So I'm going to go ahead and fill in some x values that are directly to the left and to the right of my x coordinate of my vertex. Once I've got these x coordinates, I can go ahead and evaluate each of these points in the function to find my y coordinates. Right. For the sake of time on this video, right, you can pause it here and calculate all of these, right, to get your y coordinates. Right. So once I evaluate each of those in this function, I'm going to get my y coordinates. Right, and I know that I can plot these as actual ordered pairs on my coordinate grid. Right. So in red, I wrote those ordered pairs out. What I can do next is take these ordered pairs and actually graph them. So I'm going to start with 2, 0. I can plot that point. Then I can go 3, negative 3. I've plotted my vertex in blue. I can go 5, negative 3, and 6, 0. All right. So now that we've got these 5 points plotted on my coordinate grid, we can kind of see the shape of the parabola, which tells me that I can go ahead and draw in that curve, connecting all of those points together. That was my third step in graphing. My fourth step, right, which was the last part of my directions, is I want to go ahead and identify the different parts of this parabola here. Okay. So we've already identified our vertex. We know that that's 4, negative 4. Okay. If I want to identify my zeros, right, that's where it crosses the x-axis. Okay. I know that that's going to be at 2 and 6. Right? We can also see it in our chart. Right? My zeros are where my y coordinate is going to be 0, and so my x values that satisfied that were 2 and 6. My y-intercept is going to be where it crosses the y-axis, right? We identified this up on page 1, right? At f of 0, it's going to be my constant term, which is 12. My domain of this function or this parabola is going to be negative infinity to positive infinity, right? There's no endpoints on this parabola, so I know it's going to extend in the left and right direction. So I would have all real numbers or negative infinity to positive infinity. My range is going to be my list of my y values. Right? We can see on this coordinate grid, right, that the lowest y value I have is at -4, and that's included in my graph. And I know that it's going to go in the positive direction with no endpoint, so it's going to go to positive infinity. Since my parabola is opening upward, I know that my vertex is going to be a minimum value. Right? And then very last thing that we can identify is my axis of symmetry, which is going to cut my parabola directly in half, and it's going to go through the vertex, and that's going to be at x is equal to 4.